Hello, class. This is Elise from Advanced Quantitative Reasoning. Just going to go ahead and go over this tutorial. This tutorial is basically on making decisions from cyclical functions in science and economics. So we have a couple of things right here. I just want you to recognize this stuff from this sinusoidal wave. We got this thing right here. It's going up and down, as you can see. And there's a couple of things that we need to go ahead and take into account. First off, this point, we're going to call that CD. This controls the up and down movement of the graph. This is also what we refer to back with that function. Remember, you have to remember this function. Y is equal to A sine times B times the quantity of X minus C, close parentheses, plus D. And remember, this right here is where D is. That's also where we get our CD. That's what those numbers are from this particular thing. So we can just take those numbers, plug it in. Well, besides that, we have a couple other things. I'm going to go ahead and look at this. We also want to explore this guy A. A is also what we call amplitude. This is the distance from the middle, or from C to the highest point according to our Y. You know, we're looking at the distance from D all the way up to the crest. We're only looking at the Y coordinates in that case. So we take the amplitude. If we take Y max minus Y minimum and we divide that by 2. So whatever that is, we're going to go ahead and take it. And we can get that from the range that we get from this particular thing. We'll explore that in just a few minutes. Finally, for the period, we're looking at the distance between the two crests, just like this, or the distance between two of the troughs, or the two minimum values or valleys. And you know, the crest is from maximum to maximum, minimum to minimum. We also have something called frequency, which is 1 over the period. So if we wanted to get the frequency, we can get that, and that's always written in Hertz. And that's a very good thing to understand. Alright, so we got all this, which is also, if we got our frequency, we have a few other things, but we can talk about that. The only number that we have missing here is our B, which is phase shift, but we'll talk about that in a few seconds. Now, if we take a look at this information, we're given a microphone that records a frequency tone. It's just like going beep or something like that at different tonal levels. You got beep and beep, and you got that sort of stuff. Yeah, it's kind of weird. All right. So first things first. Okay, so if x from z, which is this point and this point, represents a crest, what is the period of the sound wave? So what they're asking is, what is the distance between these 2 points? And that is the maximum from maximum to maximum. So to go ahead and calculate that, you take your x part of each one of these ordered pairs. So 0.0076 minus 0.0054. Now if we do that really quick here on this specialized calculator that is just for me, well actually I have this for everybody. Okay, so let me see, 0.0076 minus 0.0054, that gives me 0.0022. I didn't want to do it by hand, I just don't want. So that's our period, and this is in seconds. So every 0.0022 seconds, we have we go ahead and start a new period, which means we go through a cycle. So each time we have 0.002 seconds go by, there's a new cycle. All right. So frequency of a sound wave can be found by taking the reciprocal of the period. So that's really easy. So all we need to do is take 0.0022, just like right here, and flip it over 1. That would give us 1 over 0.0022. If we actually do this, we go ahead and have this right here. Alright, so we have this right here. And I made a mistake. Yeah, that's seconds. That's Hertz. Yeah, I got that. got all that ready. So right here, this if I take 1 divided by 0.002, that gives me, well, I only did 1 2. I gotta make sure I put 2 2's. So 454.54, and that repeats. So I just put 454.55 hertz, and that's all there is to it on that. So that's the hertz. Now B is represents a troll. What is the amplitude? Okay. Okay, so what is the amplitude of this thing? Sorry about that. So our amplitude, you probably look at that, is just given by this. We look at the maximum range and the minimum range. What you're probably thinking is their maximum y anytime y is at its peak or at its lowest. So the lowest y we have here is 2.5, which comes off of actually this particular thing, 0.065 comma 2.5. So this is the lowest that y can be. The highest that y can be would be like here at point z 0076 comma 65. So the biggest it can be is this. So you take your maximum y and your minimum y and you subtract them. So doing this very, very quickly, I'm going to rewrite this a little bit. You're going to take 6.5 minus 2.5 and also divide that by 2 to find our amp or amplitude. That gives us 4 divided by 2, which is equal to 2. So that's it. So if you didn't know this about sound waves, frequency actually controls pitch. So that's the pitch of the sound. Basically, it's whether you're going to have a B or an A. Well, that's musical terms. So those of you who have taken music will understand that. And the amplitude is actually our volume. That's how strong or how loud the sound can be. So we have pitch, which goes that's pitch. And then we have volume, which right now I have a very small volume. And then you just let that go and you have a very large volume. So the bigger the number, the larger the volume. The bigger the number for pitch, the higher the pitch it is. All right. So to go ahead and produce a sound that's twice the loud, okay, you just need to multiply the amplitude by 2. Alright, so it's asking about the domain and range. Well, if we take a look at our graph again, if we look at the domain of this thing, that's talking about our x. X keeps on going this way and that way, to the left and all the way into infinity, and to the right into infinity. So it's all real numbers. Our range, though, is specific, very specific. We only talk about, when we talk about range, we're talking about how far up y it goes and how far down y can be. So our smallest value is 2.5, our biggest value is 6.5. So y is always in between that. You can even see it right here. If I go ahead and draw this line right here, I have y. Y can be any number in between 2.5, which is right here, and 6.5, which is over here. So that's our range. And that's how I write it. Domain is this symbol, which stands for all real numbers, or you just can write all real numbers. Range can go from 2.5, which is less than or greater to y, because y is in between there, and y is also less than or equal to 6.5. We say equal to because of the fact that our value of y can be 2.5, and it can also be 6.5. Okay, so if Lucifer, well, let's not talk about that. We'll talk about these things later. Oh, that'll be inside of our class, so don't worry about that. So understand this stuff. This is what we're talking about, amplitude, and all that. Let me see. Okay, this is one more little thing I want to go ahead and make sure you guys understand. How to find B. And all this mess, we have not found B yet. And actually, B is kind of a weird thing. Let me go ahead and get a fresh sheet of paper because that's good. Now we have our period. Our period is equal to 0.0022. Our b is related to this. B is equal to, let me just make sure something, has to do with pi. I looked that up. I had to look this up. Alright, so according to this, B is right here. This is the period, is 2 pi divided by B. So if I work this out correctly, so 2 pi divided by B. So period is equal to 2 pi divided by whatever B is. So in other words, we need to find out what B is. Well, this is a really easy way to do it. B is equal to 2 pi divided by P. So if we ever need to go ahead and find B, if you have the period, you can go ahead and find out what B is equal to. And B really is what we call the phase shift. B controls this part of the graph. We have the start of the graph, and basically what it controls is this. It can control how many periods will fit inside of 2 pi, depending on the size. So if I were to go ahead and do this, B controls this. If B is a big number, that will make this and do a vertical compression. It'll go ahead and make the wave become smaller like this, or something like that. This is called a horizontal compression. So the bigger B is, the more compressed it becomes. The smaller B is, it will make it stretch out the other way. This is a horizontal stretch. So horizontal compression, horizontal stretch. A does much of the same thing, except it's in a different direction, and it's a different way. Okay, now I got it right here. If A is really small, then the wave will be compressed vertically, and this is what A controls. If A is really big, it becomes a vertical stretch, which it goes ahead and stretches even more. So as you can see, that's what happens. We're going to go ahead and talk about more of this in class. Hopefully I answered a lot of questions today, or actually if you have any, please write them out. Now remember, when you're watching these recordings, write your notes at the same time as you're writing. I'll go ahead and if you need to go ahead and rewind to take a better note, that's fine. That's what it's there for. Alright, I'll talk to you guys later.